In this video, I'm going to continue where I left off. I last connected the PS2 keyboard into PPI2, and as part of that, I have this keyboard interrupt. Either a rising or falling edge, I can use either here to essentially trigger an interrupt for my 286 processor. Now to actually do the interrupt handling, that's going to get me into this interrupt controller. And so this is what I'm going to now work on is getting into this programmable interrupt controller. I did a previous video where I walked through and built out these connections in the schematic. But now what I've got to do is actually go ahead and get these connections set up. And so as I look at this, I think what I have going on is I'm going to have pull downs that I am going to put on all of these interrupt lines. And then I'll bring my keyboard over to this, and when it has an interrupt, in the last video you saw that it would flicker that LED, this LED right here. And so when that pulls it high, so instead of the resistor pulling it to ground, it'll bring it up high, and then that should trigger an interrupt in this priority interrupt controller. So that is going to be that connection. These will just get all pulled down to ground for now. I'll have to hook up bus A1. I have an interrupt controller chip select, and that will come from my PSOC up here. I have IOWC and IORC. I've used those on other devices up to this point. And then I've got my 8 data lines and power and ground. So that should be about it. So I'm just going to take a minute here and go ahead and get these connections going. Okay, at this point then, if I take a look at my interrupt controller, I have connected the IRQ controller chip select up to the appropriate output of my PSOC, which the PSOC is doing the decode of the address just to get to that interrupt controller. And maybe if I open that up real quickly just to verify. So I will open up what I have for build number 2 here for the PSOC. And let me take a look at the logic. So this is my interrupt controller. And if I go look at the decode that I have to the right, I know that PPI1 is working because I'm using that. Let me zoom out here. And I also have ROM and RAM. I know those are working. And what that's left me with is PPI2, which I'm going to have to be testing here pretty soon with the PS2 keyboard, a math coprocessor, which I'll worry about at another date, and then this I/O interrupt controller. That's what I'm working on right now. So I'm putting that at address 10 hex. And so 10 hex should get me to this. So 10 and 11 will let me should let me program this, and actually it might be 10 and 12 that I need. Let me just verify I've got this correct. Yes, so this is A1, not A0, so A0 doesn't matter what it is. Nope, that's not right. I need to stop at A3, not A2. So I think I can take this out because I want to go with 10, 12. So as I think about this, I'm guessing that that last bit I can't really be doing anything with. I need to stick with evens. So 10 and 12. But then that means, let's see if I've got this A1. If I say A1 has to be 0, so I think I need to pull this last one out of here. And let me just do a calculator here to think through what I'm talking about here. So if I go to binary and I go with what I've got up here, so 0, 0, 0, and then I'm saying I want a 1, 0, 0, 0, and then the last bit wouldn't matter. So that's a 1, and then if I go plus 1 to that, that got me to my 11 hex, but then I really need to go plus 2, so it's 11 and 12. So if I look at a 12, it looks like that. And so that means that this last A1, which would be this bit here, I can't force that to 0. So I think I need to pull that off. And I'm still fine. I don't have any other clashes with other decode here. So I think that's what I need to do. I need to update this to be a 6 input, which then of course that messes all of this up. And let's see what kind of mess we've got here. So this bottom one I can get rid of. So now if I come back to my interrupt controller, let me just think through this for a second. So that I have my A2, A1 will be my, I'll go from a 0 to a 2, and I'm starting out with a 1, 0 as my base. This would be the base of 1, 0. So that would be a 1, 0, and then I get to my 1, 2. If I go higher than that, like a 1, 4, then that means I'd get into this one. So this decode should be okay for what I'm looking for. And if I go back over to the schematic, I am pulling bus A1 to this, not bus A0. So I think that's what I need, is what I'm seeing here. Okay, so that means that this PSOC has to be updated. And so I'm going to use this programmer here to update that quickly. And interestingly, I found that there's one of these pins I've connected that no longer lets me program it while it's in the circuit. And I haven't tried to dig into, well, which pin is actually causing a problem here. But one of the pins is conflicting with one of the programming pins, I think. So I've got just my little plug-in for my USB here, which I'm going to put over to the left side if I can fit this in. And actually it doesn't really matter because I've got to pop that out. Okay, so then this would normally sit like this, so I just need to make sure I've got my ribbon cable on here like so. I'm going to go ahead and plug this in and make sure that USB is powered up. And I can now see I've got power to it. And then from this tool here, I am just going to go ahead and program that. So it's this button here, and it should run through. And at the end, down here at the bottom, it should show me that it successfully completed that. And that's so much easier than having to mess with wires. Okay, device was successfully programmed. So I'm going to go ahead and flip off that USB. And now I can take this off and carefully plug it back in, making sure that I have it in the right position, power, ground. Those are my indicators that I can go off of. Okay, so that is back in, and that's been reprogrammed. That was easy enough. So I think that is correct, and I guess we'll find out when I get into the actual programming of this, but I'm pretty sure that that was an appropriate change that was needed here. These ones further down, I'm not using A2 because they're using a larger range. They actually have more than two ports that I need to work with. For example, with the PPIs, they're using 4 different ports. So that would mean that I can go down to A3 and leave A2 and A1 for that addressing. And you can watch my previous video where I talk about that. Okay, so that's been updated. Going back to my schematic, then I've got that chip select, then the output of that coming into my PIC, and I should probably verify that if I go look at this, I am pulling low. So if all of the right values are set, I'm going to bring down. And so then I need to make sure that on my interrupt controller, this chip select is a low. So I'm going to real quick pull up the data sheet for that just to take a look. So this is the 8259, and I just don't want to make an assumption that that chip select is a low, and it is. So I can see here it is it's got the bar over it, so it is an active low. So that matches what I'm doing in my PSOC. Okay, so that is connected. I then ran my IOWC and RC. Those signals are coming from my bus controller up above right here, and we've used those in previous videos. And then I have my data lines, and for the data lines for this, I just came up to my transceiver for the lower. So I've got a pair of transceivers there for data. That'd be these two. And the one on the right gives me data 7 through 0 going to the bus. So it's data in from the processor, the low byte, out. So I just tapped in right on the output of that chip rather than coming over to the bus, which should be perfectly fine. So stuff on this side I'll keep on the breadboard. As I get over here, then I can pull off of the bus board. So I brought those down. So I got my data lines, and it should be going from 7 on down to 0 and 7 on down to 0. And then on the right-hand side of it, I've got this SPEN, and right now I've got that pulled up to VCC through a 3.3K resistor. And then I've got a line that I skipped, this CAS, so none of these CAS lines are hooked up, and I'll have to get into that on a later video to understand what those are for, but I think when I initially looked at this, those were not something I'm going to use. But then I've got all the actual interrupt lines, and I can take out this note, I did add in a 3.3K resistor network, and I bent up a pin, so the bottom pin basically is sitting right above this CAS position, but it's bent up, and then that is running to my ground up here. And so each of these interrupt lines then is through a 3.3K resistor being pulled to ground. And I believe these are all active high when we get into these interrupts. And again, I can go back to here just to validate that. But if I look at this, these interrupts don't have a bar that tells me they're active high. And if they are active high, then I probably also need to understand the clock. Is it a rising clock that triggers these? Yeah, so it's a low to high transition. So low to high transition, that should also then match. I can come over here and I'll have to, this one wire I have not hooked up yet, and I intentionally left it out, and maybe I better put something in now before I forget. So I've got to get from here to over here. Then what else do I have plugged in? I've got bus A1. So A1, I just came down here and grabbed it after the transceiver chip on this side of the system. Again, I don't need to go all the way out to the bus bar to get that when it's right there. And I think that's it. So if I have understood this chip correctly so far, I think this is the physical wiring for it. And it's definitely messy here. And let's see if I can just maybe at least get this out of the way a little bit. Okay, that's as good as it's going to get for now. So I have my purple cable coming over, and that is going to give me that interrupt when I need it. So I think at this point we have this PPI connected to a keyboard. I will have to now program two things. I've got to program this interrupt controller, and I've got to program this PPI. The PPI, I have confidence in that because I did this one already, so I don't think it's going to be anything too crazy from that. So that should be straightforward. The interrupt controller is really new to me, so I've got to figure out how to use that, and then all of the code that's going to go on the ROMs to support that. So that is an upcoming video, is for me to get in and see if I can establish the right interrupt vector tables, get a procedure in place so that when this interrupt hits, I know that it's this interrupt. I can call a specific procedure and then do something. And I'll probably just start really simple, that as it receives an interrupt, I'm going to just maybe throw a character on the screen, just a character, not the actual character that was typed. And so if I can validate that that is working, then the next step would be, when that does happen, go to the PPI and read the actual data, which this bar graph was showing, that tells me my scan code from the keyboard. If I make it that far, then I can work on converting scan codes to characters, ASCII data, to push out to the LCD. So 3 more steps. Figure out how to program the interrupt controller, then grab data from these shift registers, and then finally convert it to ASCII data so that I can push it out to the LCD.